Alright, number 14, take 2. Okay, on the previous video I factored the denominator incorrectly, so here we go. The domain is all x such that x cannot equal plus or minus 2. And so it does have a hole, so that part is still true, but it's not where I had said originally. So right here, this creates a hole, and it's going to be at x equals negative 2. So we cross it out. Okay, and the y-coordinate would be negative 2 minus 4 over negative 2 minus 2. So that's negative 6 over negative 4, so that's negative 3 halves. Okay, x-intercept, well, the remaining factor in the numerator is x minus 4, so 4, 0. The y-intercept, we cover up the x's. Again, I prefer to just cover them up right here. It's just as easy. So we're left with negative 8 over negative 4, so that's 2. Vertical asymptotes, well, negative 2 is the whole, right? So that means that only leaves you with x equals 2, positive 2 as a vertical asymptote. This one's the powers equal function, x squared over x squared, so the leading coefficients are 1 over 1, so just 1. And this one has no symmetry because when you replace the x with a negative x, the denominator turns out to be the same, but the numerator is not the opposite. And it's not the same either as the original. So this is none. So on the right side we have a dot at 4, 0. So that's enough to help us graph this curve, this branch right here. On the left side we have 1 point and 1 hole, so again that's enough. From the hole I'm going to go out towards the dot, towards the asymptote, and then on the left of the hole just going to continue and draw towards the asymptote, and there's the function. Alright, so the domain for this one is all reals because nothing makes the denominator 0. There are no holes because there is no common factor in the numerator denominator. X-intercept is 0, 0. So again, remember, whenever that's the intercept, then it has to be the y-intercept, one and the same. Vertical asymptotes, we have none. This is a top-heavy function, so we're going to divide, so x squared plus 1, x cubed, so we get x cubed plus x. Well, the rest is a remainder, so this is the only thing we care about right now. Y equals x. This one is actually odd, okay, because when you replace x with negative x, okay, you have to do it at all the x's. The numerator is negative x cubed and the denominator is x squared plus 1. So the denominator stayed the same and the numerator is the opposite. So that means that the overall, you get the opposite of the original. So it's an odd function. Alright, so we have the asymptote and the intercept. We know that the function is odd, so I'm going to see what happens at f of 2. So 2 cubed is 8, and 2 squared is 4, plus 1 is 5, so this is 1 and 3/5, so a little bit more than 1 1/2, right? So at 2, I get 1 1/2, so it would be about, or 1 3/5. So that'd be about here, okay? And so that means because it's an odd function, negative 2, negative 1 3/5 is also on the graph. So negative 2, negative 1 3/5 would be about here. Okay, so with that, this curve goes under a little bit like that, but it goes towards the asymptote, and this one goes above it. Oops, too much. And then it goes towards the asymptote, like that. Alright, so 16, we have difference of cubes and difference of squares. So in the numerator it's difference of cubes, and this is how you factor that, right here, and then the bottom difference of squares. So domain would be all x such that x cannot be plus or minus 2. there is a whole because I have a common factor in the numerator and denominator, right there. The whole is at x equals 2, and so we cancel that factor. And to get the y-coordinate, we replace the x with 2's and whatever remains, so 2 squared is 4, and then 2 times 2 is 4, and then plus 4, and then denominator is 2 plus 2 is 4. So I've got 12 over 4, so that's going to give me 3. Okay, so 2, 3. X-intercept, well, nothing, no real number in the numerator makes it 0, because that second factor in the difference of cubes or even in sum of cubes, this factor does not give you any real zeros. Okay, so this, it gives you imaginary zeros, but it doesn't give you any real zeros. So you could either put the empty set like that or write the word none. The y-intercept, you cover up the x's and you're left with negative 8 over negative 4, so that gives you 2. Okay, vertical asymptotes, well, we still have that negative 2, right, for that makes the denominator 0. Remember, we can't say 2 because that's a whole. This one is top heavy, so we're going to divide. X squared minus 4, x cubed plus 0x squared plus 0x minus 8. So x squared into x cubed is x cubed minus 4x. Well, the rest of it is 0x squared is 0, right? So there is no x squared left, only a x. So the rest is remainder. So this is going to be y equals x. As for symmetry, this one is going to have none, because when you replace the x with a negative x, you do not get the original function back and you do not get the opposite. Alright, so on the right side of the vertical asymptote on this side, I already have a dot right there, a point, so I know the curve has to go up here. On the left side, I know it cannot go on the top above the slant asymptote, because that means it would have to cross the x-axis again, or at all, it has to cross it, and it can't cross it because there are no x-intercepts, right? So it cannot go here, so it has to go down here somewhere. So in order to find out where, let's pick a value for x. Negative 4 is good. Something on the left of the vertical asymptote, so f of negative 4. So doesn't matter which one you pick, negative 4, so that's going to be 16 plus, or minus, right, minus 8, or negative 8, plus 4. And then negative 4 plus 2 is negative 2. So 8, 12. So that's going to give you negative 6. So negative 4, negative 6. Right about here. Okay. So you just draw your curve towards the asymptote. Towards the asymptote. Same thing on the bottom. I know I'm going to run into that long division, but that's okay. So there it is. Those are your two curves. Okay, so the domain is all x such that x cannot be negative 1 or 3. Okay, no wholes because there are no common factors in the numerator denominator, and x-intercept would be negative 3. That's what makes the numerator 0. Y-intercept, again, I can plug in zeros here for all the x's, but let me just go ahead and quickly do the multiplied form, so negative 2x minus 3. So we cover up the x's and we're left with 3 over negative 3, which is negative 1. Vertical asymptotes, there are 2 of them. That's what makes the denominator 0. This one is a bottom heavy. And for number 17, there is no symmetry, because when you replace the x with negative x, you do not get the original back and you do not get the opposite. Alright, so for 17, the asymptotes are on and the 2 points. So I'm going to pick, say, x equals negative 2, just to see what happens in this area right here, whether it's going to go up like this or it's going to come from the bottom like this. Okay, so I'm going to put -2 as one of my points, one of my x values. So -2 plus 3 is 1, and -2 plus 1 is -1. -2 minus 3 is -5, so this gives me a positive 1/5. Okay, so I know that right here it's going to be so close, right about here. So it's going to come in this way, cross at -3, and then just go towards the asymptote like that. In the middle section, I know the graph is not going to cross up through the x axis, so I know that from this point it's going to go down, and from this point it's going to go down. Okay, on the right side, I'll pick, say, 4, so f of 4. So 4 plus 3 is 7, 4 plus 1 is 5, and 4 minus 3 is 1. So 7 over 5 is 1 2/5. So 4 is 1 2/5, so that's about here. And again, that's enough to know that the curve is going to go out like this. And there's the graph. So the domain here is all x such that x cannot equal 2. No holes because there are no common factors in the numerator and denominator. The x-intercept is 0, 0, so that means that y-intercept is also 0, 0. Vertical asymptote is x equals 2 because that's what makes the denominator 0. This is a powers equal function, so leading coefficients are both 1, so 1 over 1 is 1. And the symmetry for this one, actually it's not even because you don't get the same function back, and it's not odd because you don't get the opposite back, so it's none. Okay, so the asymptotes are on there and the intercept. So from the intercept, I know that the curve is going to go out like this and curve in like this. I'll pick 3 as a point, so f of 3. And so 3 over 3 minus 2, which is 1, so it's 3. So 3, 3. So again, that's enough information, enough to draw your curve right here. And that's it. Alright, so the domain for this one is all x. This is number 19. All x such that x cannot be 0 or 3. Because those are the numbers that make the denominator 0. This one does have a hole, and because this x cancels with one of these x's right here, so there is a hole at 0. Okay, so you're left with 3x over x minus 3, and what you get is 0 over -3, which is 0. So there's a hole at 0, 0. Now this is where it gets a little tricky, because not tricky, but just x-intercept, because it's actually a hole, we say it's none. Because I know the numerator would be 0 up here, right? And we always look up here for the x-intercept. The thing is, because it's a hole, we say that the x-intercept is none. Y-intercept would be, can't even have one, right? Because right here, x cannot be 0, so none. Vertical asymptote, x equals 3, because that's what makes the denominator 0. And this is a powers equal function, so 3 over 1, because the leading coefficient is 3 and the leading coefficient here is 1, so 3 over 1. And as for symmetry, this one has none, because when you replace x with negative x, the numerator is the same, but the denominator does not give you the same, and it does not give you the opposite. So it's none. Okay, so we connect, there's a hole at 0, 0, so that's okay. We use that to draw our, like the anchor for our branch right here. And I'll plug in, let's say, f of 6. just to get a number on the other side of the asymptote or the vertical asymptote. So 6 times 3 is 18. 6 minus 3 is 3,